Testing, testing. Testing, testing. One, two, three.
Testing. Okay. Welcome to RITSEC. Oh, oh, we're good. Okay. Make sure you guys join the Discord if you have not. Make sure you guys sign in as well. We'll be checking with pizza. Make sure you sign in. Make sure you guys check the calendar. RITSEC mailing list as well. Now, guys, clap it up for the sponsors. All right. Thank you. Make sure you follow our social media. All right. Now for announcements. Did you guys do a call up this summer? Make sure to scan this QR code. We might have one coming out about next summer as well. Make sure you guys sign up for ISTS Black Team. The competition's from February 28th to March 1st. Sign-ups close on November 26th. Yes, Leah? All right, wait. All right, February 27th through March 1st. Blue team signups are not happening yet, but if you want to, actually no, there's no blue team signups. I'm sorry, but white team signups will be posted later, and you can sign up for black team now if you still want to be involved. There's more information with this other little QR code right here. Now the WESIS last call for challenge authors. If you guys want to make your own challenge for the CTF, scan this QR code here, and they're due on November 10th at midnight. You can compete online or on campus from November 14th to the 16th at 5 o'clock to 5. Also, there's junior tech lead applications are open. If you guys want to be the next tech lead, sign up to be the junior tech lead. And you'll attend the general meetings and set up the demos. And it's a good experience to have. And yeah, if you have any questions, don't be afraid to reach out. Also, OT Security Interest Group has a guest speaker from Avangrid, Christopher Cotter. He's talking November 18th from 5 to 6 at the Air Gap Cyber 2750, so make sure to check that one out. And now we have Intro to Black Team by Leah. How was IRSEC? Was it good? Yep. Everyone liked IRSEC? That's all right. Oh, yeah? Oh, that's cool. Alternate presenter here.
I learned that there's obviously no way to do speaker notes.
Oh, there was a way, but
No, there's no
it's
way.
difficult. It's difficult.
Okay, ready? If we do the, yeah. Okay, let's not have my Slack on there. And then presenter view. And then bring this over here. And then if I do like, yeah, that works well.
Want to make it bigger?
No, I'm not. That's okay. I think I did. Leah cybersecurity. This is from like an
You got
open
the
house.
cybersecurity on there too.
It's because there's like an open house, guys. Okay. It's like a accepted students thing. Oh, no, please. Please, presenter view. My bad game. I start? Yep. Okay, cool. Yo. Hello, everyone. We ready to learn about Black Team? I'm Leah. We're going to talk about Black Team today. So, who am I? I am Leah Kvaris. I am a third-year cybersecurity major. I'm also minoring in MIS and music performance. I am your current ISTS competition architect. As Adam just announced, Black Team signups are open for ISTS, so if you're interested in that, if you already signed up, you can learn more. If you haven't signed up, I'm gonna tell you all about it. So we're gonna have like the most goated Black Team of all time this year. I was the head of education last year for RITSEC. I'm on the CCDC team. I've been on Black Team since like the first time it was possible for me to be on it, and I've been on it for the whole time. My credentials to give this presentation, I guess, is like spring semester 2024, I was on ISTS Infra. Then I was on IRSEC Infra that same year in the fall. Then I was Infra lead for last ISTS, and then I was on Infra for this past IRSEC. And I guess, yeah, I'm a CA. What else? I'm on Red Team. I was the first ever Slidely Cup winner, guys. If you don't know what that means, we have Slide Roulette coming up. You'll hear more about that probably from Adam, but that's pretty cool. And I do a lot of performing arts stuff. Audience participation. Can you guys raise your hand if you know who Dan Povenmire is? Okay. Can you raise your hand if you know who John Hammond is? Okay, that's it. Garrett's not here, but pretend that everyone knew who John Hammond was. I met him right there. All right. I'm not changing slides. So what are we going to talk about today? First of all, we're going to go over the competition types, then the Black Team organization for each of the competitions, and then we'll talk about Terraform and Ansible, which are the things that we use to put up these competitions. Competition types. So, red versus blue competitions. You guys probably have heard a lot about these because that is what IRSEC was. IRSEC stands for Incident Response Security Competition, and it is a great example of red versus blue. So if you were a first year or just if you signed up for IRSEC, it is our beginner-friendly red versus blue competition. And the way that we operate with these is obviously you guys had like PCs in front of you, and then you would remote into virtual machines that we had set up in our virtual environment, which is OpenStack. The theme and the environment change every single competition, so that means that, for example, this past competition was time travel themed. Last year's was fictional Cold War. The year before that was casino. I was about to say gambling. Casino, same thing. So it's always something really fun and creative. I think a lot of people consider the decorations of the room when they pick out their theme, but then also everything in the competition is shaped to the theme. So like the box names, the roles of like what you are as the blue team, what the red team is, like fictionally, all of that changes. And then the environment, meaning the types of VMs that are in it. So for example, we had Windows 10 for like a lot of Windows Server 22, I think, very specific operating systems, Ubuntu 2204, etc. So the blue team's role in these competitions is to defend, as you probably know. The blue teams are teams of 5 in IRSEC and ISTS. And what they do is red team pre-bakes, which means that they get access to the virtual machines before you. And they put their malware on the machines, they put their implants, they hide everything really well, and then they make sure that they're getting callbacks to their C2s, back to every tool that they have, so that we have I'm on red team, but so that red team has persistence to all the hosts, so that you, in turn, as the blue team, go in, find evidence of malware on the system, whether that is files, whether that's traffic, and then sometimes you have to talk about it in injects. Sometimes at the end of IRSEC, for example, there's an incident response report, which you all wrote. And yeah, this is all meant to be an educational experience for you to understand, like get familiar with operating systems, get familiar with what looks normal on a system. That's really important. And yeah, kind of get better at threat hunting, incident response, that kind of thing. And this graphic I created, it means that red versus blue competitions are the bread and butter of RITSEC. Yeah. And yeah, examples of red versus blue competitions, I just like heavily leaned on IRSEC as an example because it was really recent. ISTS, which I will talk about more, is another, has a red versus blue component, but not necessarily the main focus of ISTS. And then things like UB Lockdown, which is University of Buffalo's, like NetDef is their cybersecurity club, their competition that a lot of RIT students like to go to. And then the Collegiate Cyber Defense Competition is also a red versus blue competition. The next type of competition is a CTF, which stands for Capture the Flag. I guess you could describe it as a Jeopardy style competition. This is more of like, there's no like live traffic from a red team or anything like that. This is standalone challenges that people build, and then you go in and solve them. So there's different categories, which is why there's like a little Jeopardy graphic. The most common categories are stuff like web, pwn, crypto. OSINT is a fun one, and then Fortnite item shop. I don't know. I didn't make that. I just kept it from the last presentation. And examples of this are, for example, the upcoming WESIS CTF from our WESIS chapter, the RITSEC CTF, which happens in the spring, and then Seesaw, which also is happening like right now, I think. So yeah, CTFs are more like the general, how I see it is a lot of other cybersecurity clubs at other schools focus just on CTFs. But then, like I was talking about, like red versus blue is our bread and butter. So there's different kind of like angles that you can go at with gamifying cybersecurity education. And CTFs are a little bit more widespread because they're a little bit easier to put up with things like CTFD. Then there is something called COTH, which stands for King of the Hill. So this picture, I think I literally took it from Hack the Box or Try Hack Me, because these platforms are the kinds that use like this format of learning. What COTH is that there's multiple or standalone hosts that have built-in vulnerabilities. So if you've heard of people like in RVAP doing Hack the Box, that means that there's some kind of like VM, you know nothing about it, so you have to do reconnaissance on it, right? Like scan it with Nmap. Then you have to figure out what's on it and then go through different attack vectors. So like a really simple example is if port 80 is open, you'd probably try to visit like the web page on that host and then figure out like if there's a web vulnerability, like if it's running WordPress. WordPress is a very common example where you exploit things, and like it's not like custom stuff. You can probably find references online for it, but that's an example of that. If it's like a combination of machines, a big category is like Active Directory exploitation. So understanding the relationships of machines in Active Directory for Windows, and being able to use those to like hop from machine to machine to get DA eventually, domain admin. And for example, in ISTS, we have a whole COTH component. So other than when in ISTS we have like the blue team sitting in this room fighting off red team, they can also, if things aren't going well, or they often like bring someone specific on the team to focus on COTH, they can go and sit on like the COTH network and try to hack into the boxes on there. So this is more of like the offensive, not just like kicking out red team. It's more finding the box, exploiting the vulnerability to get into it, and then claiming it with a token. There's different ways to prove that you actually hacked into it. On Hack the Box, for example, when you like own a box, you just like read a user.txt file or an admin.txt and then submit it. So kind of like a CTF thing. But then in our COTH, I might explain this wrong. I didn't do COTH, but we have like COTH tokens that you put in your own, and then once it's on that system, it's claimed as your team's. So yeah, I think I explained that pretty well. That's the get in, stay out, keep others out. Once you claim it in ISTS, for example, you want to secure the box. So yes, it is a vulnerable host, and you should have found maybe one of multiple vulnerabilities on it, but now you want to like claim it, like keep it on your team. So you want to secure it so that other teams can't claim it. And then I guess I should have put RITSEC competitions first because I've been referencing them a lot, but we'll talk about what makes up the IRSEC black team, for example. I pulled these numbers before IRSEC happened, so they might be a little bit different, but we had about 33 black teamers setting up IRSEC on all of those like black teams within the black team, and then we had 18 white team members run by our white team lead to help set up, which again, I will explain what that is. But yeah, the black teams for IRSEC are pretty simple. We have infra that puts up all the boxes to make them ready for Linux and Windows to deploy to. Linux and Windows, in turn, configure those machines that you would be working on as blue team. So again, like I was talking about in the topology, like if you have Linux boxes, all the users on them, all the custom things like the services, They were put up by people on the Linux black team. Same thing with Windows. Windows has to like disable Defender for our red team. They have to put the users. They have to set the backgrounds. All things that sound really easy, but are not really. Scoring is really important because that's how we like know who's winning. So we use Scorify, which is written by an alumni. And the way that it works is the scoring team has to like put up the minions. They have to put up the scoring server, and then write the score checks. So like a very simple example of a score check. I might be getting ahead of myself because I think this is later in the presentation, but a very simple score check would be just like pinging the box to see if it's up. And if the ping like receives responses, then it's green on the scoreboard. If not, it's red. But we'll talk about that more. Injects are also super important because that's like, you know, when you guys got handed out like pieces of paper during the competition that said like, I don't know, give us an inventory of your infra or something like that. That's created by the Injects team, and they have to work hard to make sure everything makes sense in the theme because, again, we want it to be very immersive. So it's not just like a random inject that doesn't make sense. And then they just have to have a better overall understanding of like what's a reasonable task to ask from a blue team that's kind of busy right now, and also how much time to give them for it. So this, like, injects are, it's a weird word because people put injects on their resume, and then real people like in the industry are like, what is an inject? So I call them business tasks usually, and this helps bridge kind of the idea like, okay, if you were working in an actual company doing instant response, for example, that doesn't mean that your job on the side like stops like what you normally do. So if like your boss needs something, you still need to do it while doing whatever you're busy with currently. So that's what an inject is meant to kind of emulate. Logging, also super important because we want to make sure people aren't breaking rules. So logging sets up Datadog, and they see lots of very cool logs actually from the blue teams. I'm definitely going to explain this later, so I'm just going to keep going. Store, super cool. We have a store, and it's always themed really well. Again, I keep coming back to the theme, but it's really important to the competitions. And the items on there will be named something like having to do with the theme, but then they represent, for example, a revert. So I think in IRSEC, reverts were the big bang because it's like, oh, I don't know, something's been created. So if you bought a revert, black team would go in and like revert your box. Let's keep going. ISTS black team is a little bit larger. So if you notice, I kind of kept like the left side the same, and then on the right side it's different. ISTS, alongside all of those teams within black team, also includes a Weird OS team. Weird OS and ISTS is a weird operating system. So this past ISTS, it was Temple OS, which if you don't know, does not have networking natively, but our very smart students managed to make it like networked, which was a very fun challenge for both them and then for red team also to deploy to and for blue team to defend. I don't remember what ISTS Weird OS was during 2024. Nix OS? So that's what that was. Again, like I just talked about, King of the Hill is specific to ISTS, not IRSEC. So on that side, the Koth black team are the ones actually creating the boxes, putting them on the Koth network, and then testing them to make sure those vulnerabilities work. Game is, oh, I just skipped CTF, I'm sorry. CTF, we have basically a whole CTF going on while all this other stuff in ISTS is happening. So obviously the CTF team creates the challenges, puts them on CTFD, tests them, all that usual CTF stuff. The game, super fun. The game is, it varies very heavily each year, and we've started leaning more towards like physical security for the game. And it's just something fun, something custom, something for the blue teams to have fun with alongside all of those other components of ISTS. For example, the game this past year, ISTS was bank heist themed, so we got like a giant safe that they had to break into, and there was also like other stuff, like it was like breaking into a bank basically, with like lights and like lasers and other lock picking things. And then the year before it was Wild West themed, so it was a Nerf blaster shootout, also with like picking your teammate out of handcuffs, and stuff like that. So it's something like fun, silly, but it is scored, it's part of your score, and we need a team to be able to, first of all, run the game during the competition, and also plan all those things, see what we need to buy for the game, stuff like that. And then phones is sort of a black team. At this point, it's like 1 or 2 people dragged out of a different team. But we do have like phones for each team during ISTS, so they can call each other. They can call red team, stuff like that. When you take network services, you will learn how to set up VoIP. So that's a fun time. And yeah, this is a larger black team of last year, about 52 black team members, which is pretty big. That's a big group. I felt like I needed to mention the RITSEC CTF black team. I was on it once for infra, but it is very different from ISTS and IRSEC. All I can say is it uses OKD, which is more of a Maxim and Joe Abate thing. And then the other teams are QA, quality assurance, and then the actual challenge authors who write the challenges for the RITSEC CTF. I can't really speak to this one too much. I guess we'll talk about the organization more than I did. Oh, okay. So when you think of black team, we got the competition architect. So for example, Ariana Schwartz was the competition architect for IRSEC. And then there were black team leads that report directly to the CA. So for example, Brenner was the store lead. I'm just looking at people. Philip was the scoring lead. Casey was the white team lead. So this means that they would be in direct contact with Ariana for everything, like making sure that her vision of the competition is like they're staying true to the vision and just like doing what the CA wants, because one person cannot single-handedly put up a competition. And then in addition to that, each team has just like black team members. So Brenner would have people that are like, he would hopefully be delegating to and telling them to like, okay, work on this certain feature for the store, or like do this styling or whatever it is. So these people are doing like the hands-on technical things. Not to say that the leads aren't, but the leads need to be understanding the bigger picture as well, so that they can properly delegate those smaller tasks. Yeah, and then we used to have, like it says, okay, this is like weird terminology. This says black team leads. We used to have a black team lead. So pretend that this says like Windows lead, Linux lead, store lead, whatever. We would have a black team lead between the CA and those leads as a sort of like assistant manager to the ISTS CA. Or I don't know why I said ISTS. We did try this in ISTS. And it's a role that some CAs might want just to help with like all the logistical things, because as the competition architect, you're not really going to worry about like, okay, how am I getting these users on Linux boxes? You're more so worrying about like the teams that are being invited, like make sure that everyone's in the Discord server, make sure that like the theme is going well. Like you gave guidance to the other black teams, but you're not doing the very small details that every team does, because it's not possible. More about the competition architect. Perfect. The competition architect is the big cheese. I promise I did not like, this was kind of already here on the slide. ChatGPT even knows, guys, ISTSCA is me. It's not me. This is like from when Drew made the presentation. But yeah, the CA is basically a project manager for the competition. Like I was just explaining, they don't worry about the very fine details. They worry about making the competition happen. Which includes like interfacing with RIT, the department. I'm going to talk about in terms of ISTS because this is what I worry about like now until ISTS happens. Again, making sure the teams are all set, that the teams can travel here. For example, if it's ISTS, because we invite other schools here. For IRSEC, it's more like, do the teams like know what's going on and will they show up the day of? Then the competition architect leads all the leads meetings. So that was like an unfortunate phrasing, but the black team leads, they have usually weekly syncs leading up to the competition to talk about, you know, what's going well, what needs to happen still, making sure that everything is on track to happen, especially for what we usually do is we have one long day on a weekend called deploy, which is when we make sure that everything goes green on the scoreboard, and this involves every single black team to make sure that that happens. So yeah, it all lies on the CA, the big cheese. I guess, yeah, I had more about the teams. I just like talked too soon about it, but I asked all the leads like what skills that they think are used for their specific team. So of course, again, for infra, that's what I've been doing for many semesters. We learn Terraform, we learn Ansible, networking, which used to be its own black team, but then basically got absorbed by infra, and then OpenStack, of course, because that is where we host our competitions. the operating systems, meaning Linux and Windows. A lot of them, not all of them, they use Ansible, things like scripting, and then OS-specific configuration, knowing how to actually set up like domain-joined hosts, for example. Scoring, again, Ansible Docker, knowledge of services to write those score checks. Injects, like I mentioned before, understanding cybersecurity just in general so that you can come up with creative inject ideas, just make them fun for the competitors, and also be organized because you need to keep track of who submitted what grade you're giving them on the inject, all of that stuff. And then store is more dev focused than cybersecurity usually is. So they do Git, React, TypeScript, Golang, REST, API, things to make a good website. And then logging didn't respond to me, so I put Datadog. I'm sorry, I don't got much for logging. They also helped out with, I believe they helped out with Waza for IRSec. And then I've got the asterisks on the teams that are appearing in ISTS but not IRSec, which I kind of went through already. So those are all the teams that go into Black Team. Now to talk a little bit more about infra. It didn't change, okay, that took a long time. Infra is the first Black Team that starts working. They go in because the way OpenStack works, there are different projects. So like if you've been on our RITSEC stack, basically you have in the top left corner, there's a little drop down, and then it usually has your student ID, which is what we name your personal project. So like my project is called LK3053 because that's my RIT ID. And then I can like do stuff in that project no one else sees, okay? I put up my VMs, whatever. Infra creates the project called like IRSec 2025 in OpenStack. So if there's no project, like the other teams can't go in and do anything. So that's where Terraform comes in. I think there's gonna be like a whole Terraform section later, so this is as a high level overview. Terraform creates the project, then Infra uses Terraform to create all the management hosts, which include things like DNS for the competition, because we use our internal DNS, obviously. Time.warp is not a real domain. We put up, what else? I'm just like blanking everything. Like the host for scoring, the host for store, all of those things so that like, oh, I literally have it right there. NTP, the VPNs for Black Team to be able to VPN in. Same thing for Red Team to be able to VPN in and deploy their things. And then Uptime Kuma is a cool little tool to show, it's kind of like a scoreboard, but for our management hosts. So if stuff is not working, you can refer to that once you set it up properly and then see if like, oh, okay, things aren't working because our own DNS is down. So let's fix that first. And yeah, manage hypervisor running competition means OpenStack. And Terraform is an infrastructure as code tool. So I guess additionally, we do the networking. Not so much when it's nothing complicated, like setting up the PCs in this room wasn't too bad. We did have to call in our networking specialist alumni, but the like plugging in the computers into switches into the floor doesn't take too much networking on that side. If it's something weird and interesting, then that's when networking comes in. But yeah, Terraform is kind of like the go in, create the project, create the VMs, and then after that, the other teams like Windows go in and like use Ansible to configure the VMs themselves. So Windows, I don't know who put like versions with a question mark, but they don't, this implies that they decide the versions. They don't, but I guess they deal with the versions that the CA decides. So for example, Windows 11 right now is newer, and Windows Server 2025 is newer. So those are things that we haven't seen in competitions yet, but they would be configuring those kind of operating systems. Nothing as old as XP or 95 in the time that I've seen. It's usually Windows 10, but yeah, that's a little screenshot from Connor's Proxmox when we were trying to make a good Windows image with no Defender, which we succeeded in. Thank you, Connor, for your hard work. Yeah, that was like a big task for Windows this time around. And then, yeah, what Windows thinks about as the Black Team is Active Directory, Defender, I've said that many times, putting the users, so like when you saw in the packet, there were local users, there were admin users, they have to make sure those are all good. General Windows tomfoolery. I don't know what goes on in Windows, I'm a Linux person, so good luck, have fun. And then the services that they deploy onto those Windows machines are things like Active Directory, DNS, SMB, WinRM, IIS is a good one, SQL, ICMP, kind of mid, Not gonna lie, not my favorite score check. But these are all services that you usually see on Windows hosts that are being scored. And then we get the Linux guy peeking through, because next is Linux. Linux deals with, again, different distributions of Linux. For IRSEC, we keep it more familiar, so I believe it was just Ubuntu, Fedora, maybe Rocky in there. And then funny distros like Hannah Montana Linux, Debian. I don't know when this last has been seen, but hopefully ISTS will have some cool distros, those who know. And then Linux does things like install packages, users, dependencies, make sure that services like work. Again, just configuring Linux systems. That's their whole job as Linux. And the services you'd see on Linux are, of course, SSH to get into them, especially the cloud ones, FTP, some kind of site. Again, SQL and ICMP, those also can exist on Linux. Yeah, we got a cool Linux guy with sunglasses. Here's some more about logging. So we do use Datadog. This is probably really difficult. Yeah, that's like really hard to see. You can see when you when I send out the slides, but there's just like a screenshot that I wanted to include of like some messed up logs before logging got everything working. This is what a Datadog dashboard looks like, and you'd be able to see usually like actions, especially what we pay attention to is, for example, disabling or deleting or changing the password of a white team user. That will be logged. Deleting a user like is specifically a log that I've seen. If they use antivirus, they being blue teams, because we don't allow that. And then in ISTS, logging is also really, really important, because in ISTS we allow purple teaming. And not purple teaming in the usual sense of like collaboration, but purple teaming in the sense that blue teams can red team other blue teams. So if blue teams are attacking other blue teams, and we tell them not to do anything too destructive, sometimes they don't listen. And as a result, we need to give them point penalties, and we can have logging kind of check for us, like, okay, when did this happen? Maybe what like sort of connection there was, which user they used, things like that, so we can pinpoint. If it was really a blue team attacking another blue team, or maybe red team doing something, or maybe a blue team teaming themselves, or blue team red teaming themselves, which happens a lot. So logging is really important for visibility into the competition. And yeah, logging also helps out, I think I said this earlier, with using like logging for the competitors. So in IRSEC, there was a WASA box. It was out of scope for red team, just there for blue teams to use as a resource, and logging would help with that. All right, scoring. So I mentioned we had a custom scoring engine called Scorify. ScoreStack is listed there because that's what we used to use. Scorify is great. First of all, it includes an inject submission in the app, as you guys saw during IRSEC, and it also has Koth scoring built into it for ISTS. So yeah, what you can do within it, this picture on the right is an example of writing a score check from probably last IRSEC, if I am understanding the host name. Yeah, Cold Conflict was last IRSEC. So this one is doing an LDAP check. No, it's not. What is going on? It says, yeah, it is. It is. Sorry, I read ICMP. So port 389 is where LDAP is, and then it kind of defines the team number as a variable value. So that's the way that we name our hosts. Obviously, it's hostname.team whatever .domain, and then what it's checking for there is that it can just connect with a user and a password. And then what we did try to stress during IRSEC is, if you're changing passwords, which is something that you should be doing in the competition, you also need to remember to go into Scorify and change them on your end. So I think from a competitor view, Scorify, you can just go into score check and all you see is like change password. So you gotta enter that password that you just changed on the actual system into Scorify, otherwise the score check will fail. Same thing with like, if it's an SSH score check, it's very often SSHing in with a certain user. So if the user is called score check and the password is score check, but then you change it to something more secure, which you should, Scorify will start failing the score check because it's trying like the wrong password, and it obviously won't work. But yeah, and then the scoring black team also does the final score calculations. They adjust scores if teams got point penalties, or if teams got extra points from like winning a foot race or whatever they do out there for different store items. All that is on the scoring team. Injects. Yeah, business requests. I made sure to include that terminology in here. This is an example of an inject from last year. It's always very nicely themed with the competition. So like I said before, I think I'm just repeating myself at this point. Injects, they write all of these injects. They figure out the timing and when they're released, when they're due, and then they create the rubrics because obviously we want to make sure every team is graded fairly on their injects. Then they actually spend time grading those injects with the help of white team because obviously there's lots of teams, not as many white teamers and injects members to grade them. So we have literally like the whole time they're in the back room, usually in the LaChase suite, working hard and grading the injects, and obviously they're the ones handing them out as well. Store. Yeah, guys, I didn't realize I had slides for all these. So I included a little screenshot from the store for my RSEC. It looked super cool. It was a whole timeline because of time travel theme, and it had all the events on there as items. When you buy an item from the store, there's a Discord webhook that goes off and adds like the store team or the people that are in charge of looking at what was purchased, because we're working hard behind the scenes to keep track of what everyone's buying to be able to fulfill those at like a timely manner. And the different items, for example, you can remove a team's chairs, you can take away their mice, you can replace a blue teamer with a red teamer, you can request a box revert, which is very popular. All of these things, again, they're called something silly on the store, but then they're like themed and they fit into something that corresponds with like something that you'd want to happen during the competition. And it allows for the chaos that you see in the competitions, like a team being full of red teamers using their mice, and like no chairs. They're just like kneeling on the floor. Or there's like people being handcuffed together or whatever it is. So we just try to make it a little fun. It is chaotic, but it's part of what makes these competitions a little bit extra interactive. And just so you know, when you're buying reverts, everyone's coming to me behind the scenes and telling me to revert boxes. So it's just one person. It's just like, you know the meme where it's like, this is who you're talking to, and then it's like a little like rat or like a puppy. That's me. And then, I don't know, I just have like a fun screenshot of Lucas in the store from Garrett's laptop, Docker. I don't know. White team lead. These slides change really slow. I don't know why I put the word lead there. Let's just pretend it says white team. The white team are assembled after the black team. So white team signups usually open up a little bit closer to the competition date. And these are just volunteers who set up this room. So they like help us move all the tables. They help us get out all of like the dozens of computers that we have in storage, the monitors, all the cables, keep everything organized while doing it. Keyboards, mice, switches, everything that goes into a whole setup for a team of 5, multiply that times 18. That's white team helping us out doing that. Then the decorations, of course, you know, we have like whatever decorations for the theme of the competition. They go up on the walls, on the tables, they help with that. And then, like I mentioned when I was talking about the injects team, they go during the competition, they help with injects, grading them according to that rubric that they created. And they also are very, very important to communicating between blue team and black team. So the blue teams, they're of course all busy sitting here like fighting off red team. White team should be patrolling the room, looking for people with problems, kind of assess the situation, and then find the best black teamer to help with that problem or help them out themselves, because we try to provide them with enough information, enough context to the competition to troubleshoot the basic issues. So white team are just like the helpers for the competition. We really could not do it without them, which is why I have this meme of like the white team holding up the competition, because yeah, we couldn't do it without them. That's all I have for that one. And then the other teams, it would take a while to go through, so they're all on one slide. Like I explained game, the game team just like figures out what the game is, all the details, what to buy for the game, where to have it. Like we used to have it in one of the labs upstairs, we had it in the club room upstairs, whatever it is, wherever it is, game is in charge of that. And then they're in charge of making sure that it's like happening during the competition, because it's usually supervised by a black team. CTF, very straightforward. They set up the CTF, they write the challenges for ISTS, and yeah, they just take care of the CTF side of things. Same thing with Koth. They work on the Koth boxes. They make sure that they're all created in a timely manner for the competition, and then they take care of things like Koth reverts or like whatever. If teams are having issues like redeeming their Koth tokens, claiming the boxes, they can probably help them give hints on how to hack the Koth boxes, things like that. That's what the Koth team does. And then WeirdOS sets up a very specific operating system, literally anything. It's usually really cursed. And we have a separate team for a reason because it's something very strange, not often seen, so we need a team dedicated to it. And especially, again, in terms of troubleshooting during the competition for WeirdOS, that is very, very important. Okay, let's talk about Terraform. So, like I mentioned before when I was talking about infra, Terraform is an infrastructure as code tool by HashiCorp. It's used to build, deploy, destroy resources. And then the really cool thing about it is that it's flexible with the HashiCorp language, and then that it's stateful, which means that once you run Terraform, it has a Terraform state file that's kept on where you ran it. And there's like a lot of Terraform state commands, like Terraform state, whatever, that help you understand what is deployed in the environment. And then Terraform ingests all of those details so that even if something very small changes, if you rerun Terraform apply, it will be aware of that and it will change them for you. So something very basic is if I had already deployed a bunch of instances on OpenStack with Terraform, and then I decided that I wanted to change their host names, I could just go into Terraform, change that one line, and then rerun Terraform apply, and it would know to update the instances in place. So it wouldn't destroy them. It would understand everything that is already like created using Terraform, and it would only update the name. So it's things like that that are really useful. Or if, for example, someone accidentally deletes a port on OpenStack, you can just run Terraform refresh so that it like refreshes the state, and then run Terraform apply so that it recreates that port exactly how it needs to be, which was really useful for me during the competition. Usually, I would not be using Terraform during a competition because once Red Team deploys, those instances differ from the ones that are like clean set up by Terraform, right? Because they have none of the configurations ready. They're like snapshots of a different state of that instance. But for example, when I was reverting routers, the ports were just not cooperating with me manually. So I decided to go in, delete the Terraform state, and then reapply it. And it worked. I don't even know what the difference was, but Terraform did it right, and I did it wrong. So that was good. And the way that Terraform works is that there are different providers. So the provider we use is the OpenStack provider, but there are other ones, especially like AWS, super popular one, GCP, Linode, super popular, Domino's. I remember watching this presentation 2 years ago from someone else was giving it, obviously, and they said that you can order Domino's pizza with Terraform. I don't know. I can't elaborate on that. There's something interesting coming up for Terraform, though. So more about what Terraform looks like. So the example on the right, kind of, we're going top to bottom describing what it is. So you need to have a Terraform module defined. So I just said I'm going in order. I'm not going in order. That's bottom. A module is like a common object. So in our Terraform for the competitions, a module would be called like Team LAN or Team Cloud. So within a module, we would have the different instances that go into a team's LAN network. And then, let's see. You need, first of all, information about the project in Terraform, like up top. So that means defining the provider and then the version. The source is like, if you look up Terraform providers, they have really good documentation, and you can define different sorts of sources for like the Linode provider, for example. Or for Proxmox, there are different providers. I struggled to find a good one until I finally just like tried all the different ones, and they differ in the way that they expect you to define the other parts of Terraform. So you just have to kind of read the documentation, play around with what works for you. Yeah, the provider is like the API for interactions. So with the OpenStack provider, for example, on OpenStack, you can download the OpenStack RC file, which has like the project ID and then the credentials that you use to access that project. Because obviously, if you don't have access to a project, you can't do things on it. So the way that we put up our stuff for the competitions is we have that OpenStack RC file downloaded. We actually recently started using an application credential, which is a different thing you can set up in OpenStack so that you don't hard code your credentials on a shared box with like 50 other black teamers. And yeah, that lets you interact with like the OpenStack API for using Terraform. Then variables are more like, let's see if this example has anything good. API token, that's not a great example. In our competition stuff, variables, I believe, are like the competition name and the username, if I remember correctly. Resources are a very important one for OpenStack. So resources are like the infrastructure objects that you create and manage with Terraform. And that is things like the actual instances, maybe the networks, or even things like DNS records. So the resources, they depend on the provider because obviously instance means different things on different cloud providers, for example. It's confusing to use the word provider there, but instance is a different thing on OpenStack than other places, for example. And then, like if there's a provider for AWS, then it has modules for things like S3 buckets, VPCs, like EC2s, things like that. For OpenStack, it would be different. It would have modules for OpenStack native things. You can ask me questions about this later. There's a lot. But really, the Terraform documentation is really, really good. You can even teach yourself all of Terraform with their free like open docs, and then you can take like their Terraform exam, and it's all like solely based on the information they have available for free. Great, I included a specific example. I was right. So variables for our competitions is like the name of the competition. So ICS, for example, the domain for the competition, because you want to define variables separately, so you can just change that one little value in the variables.tf Terraform file, so that when we start doing the Terraform for the next competition, all I have to do is Command F for IRSec 2025 and replace it with ICS 2026, stuff like that. And then team number, again, it's a very like repetitive thing that will come up in the Terraform. So you want to just define it once as a variable and then be able to dynamically replace it in other places. And then you can see that's the provider that we use for OpenStack. It's called Terraform Provider OpenStack. And then for the provider, we define those project names. So let me try to explain this. So for the OpenStack provider, what I was saying is when it expects those specific things, this specific OpenStack provider, it expects a tenant name, username, password, and auth URL. So that's what it knows. And then when we provide it, what tenant name actually means is the project name. So what I was talking about, my personal LK3053 project, or like the IRSec 2025 project, that's where that goes. And var.project name, again, relates to those variables defined in variables.terraform file. It would literally just be a string that says IRSec 2025. And then it's dynamically loaded into the provider. And then everything else, again, for that username, password, the auth URL is like the OpenStack API URL. And then I have another example, this time with Proxmox. This is what I used for putting up stuff on our CCDC Proxmox. Basically, again, if you see up top in the provider, very similar to what I just showed in OpenStack, the Proxmox provider expects something called an endpoint API token, right? So then what I do there is I go into our Proxmox and I get the API URL, and then I get the token, which like is for authentication into our Proxmox virtual environment. So after that, the locals are the host that I'm defining that I want to make with Terraform. The name is literally the name of the VM that I'm making. And then ISO, again, it's a variable. So you won't see it on this part of the file. It's going to be in a different file where I defined variables. And I said that, like, I named the variable server 2022 ISO, right? This is kind of like programming for variables. You can name them what you want, and then you give them a value somewhere else. So in that variables file, I made the value the actual name of the ISO, which was much longer. And this way I could just type out the variable and define it that way. So most of them were Windows Server 2022, and then there's one Windows 10 in there. I named it as a variable Windows 10 ISO. What it actually does is it points to what that image is called in Proxmox. And then I define other things for it, like memory, CPU, things like that, just for the instance to be created. And then, again, there's the resource underneath, which actually goes in, it iterates over those locals, and it creates them with the name, like with all those variables that I gave it up there. It creates that instance. And then I define other things just to make it work. Yeah, oh, okay. This is left over from a different time that this presentation was given, but apparently there's a Discord provider for Terraform. I've never used it, never tried it, but apparently you can create Discord servers using Terraform, which is kind of cool. Let me know if you give it a try. I might do it, but didn't really get around to it. So that's cool. There's, again, there's the Domino's thing, there's Discord, there's Terraform. There are official providers, and there's also community ones. So it's really like, if you figure out how to do this, you can make your own Terraform provider and just like put it on there and create Discord servers and order Domino's. Let's talk about Ansible. So Ansible is great. Ansible is another code tool for infrastructure as code. It really goes hand in hand with Terraform for our competitions. What this means is like I was describing Terraform, you just created all those VMs, but they're literally just VMs. Like, you haven't done anything to them yet. Ansible, it goes in and it like sets up a base Ubuntu VM, for example. It adds some users. It like uses Apache hosting WordPress with MariaDB, whatever you want. You can do a lot of things with Ansible. And I guess you could call it a Lego-like configuration, because the way that it works is there's an overarching playbook. Then the playbook has different roles, and then each role has a task. So this allows for like a lot of abstraction, because Ansible is meant to be self-documenting in nature. So if I have a playbook that literally is called like setup VM, right? That's like the overarching thing that I'm doing to it. Then there would be roles. These roles would like include things like add users. That would be a role. Then within the role, there would be a task to add user 1, add user 2, add user 3. And then when you run Ansible, you'll basically see all of those things appearing, and you'll know exactly where you are in the playbook. So it helps when you want to like run specific things. For example, you can separate out all of these roles to have tags, and then again, I'm gonna lean on competition as an example. In RITSEC, we run Ansible on both the Windows black team and the Linux black team. I said Windows Linux, right? Yeah. So Linux would have a tag that says like Linux, and then Windows would have a tag that says Windows. So when they run the playbook, they're not running the whole playbook. They're running parts of it that apply to Linux if they want to do Linux stuff, and they run parts of it for Windows. So it is very much like flexible to your needs, and you can have everything in one playbook and then separate them out based on what you want. Another cool thing about Ansible is that it is agentless. So that means that you're not actually, like, you don't have to have anything installed on the hosts that you're managing with Ansible. All you need to do is install Ansible on, like, your one machine. So if I want to run Ansible from my laptop, that's all I need to do is install Ansible on this laptop. And then, you know, whatever dependencies, like, I'd probably create a virtual environment, Python, things like that. But Ansible is on my laptop, and then what it does, it connects out to, like, someone else's, I'm not going to say someone else's laptop, to like the VMs I have in OpenStack, right? Those VMs, as long as I create those VMs with a cloud in it that has like one user at least, and I have the credentials to that user because I set it, in Ansible, I'm going to say Ansible, use SSH, and here's the username, here's the password, or here's the private key. Go in and configure this on the host, on the VM. So it uses, again, not necessarily SSH. If it's a Windows machine, it does not use SSH. It uses probably WinRM or PSRP. I'm going to talk about this a little bit later. I'm using this slide for a lot of information. But those, like, my laptop in this example is the control node. And then those VMs out there on my OpenStack are the managed nodes. And they do not have anything on them that makes them, like, Ansible compatible. They're just VMs. All I need is Ansible on my host. And in terms of SSH, SSH or Ansible often uses SSH agents, which means that it saves all of like the necessary details in that SSH connection. Because if you're me and you're running Ansible and it suddenly fails, or not fails, it hangs forever, it's probably waiting for your passkey to your SSH key because you didn't use SSH agents. So don't let Ansible pull your private key that has a password on it. the way that Ansible knows where to run these things, your playbooks on, is using an Ansible inventory. So by default, Ansible has 2 categories, all in ungrouped, and then you can create your own groups for inventory. So the way that it looks is you'll have like your main.yaml. Ansible uses YAML, by the way. You'll have your main.yaml playbook, whatever. Then you'll have your inventory file. It will probably be called inventory.yaml or inventory.ini, which are 2 different formats. Yeah, I have 2 examples here. So, low-key, I need the other slide, though. What the inventory does is you list out all the hosts that you want to run the Ansible on. So this can be IPs, or it can be, I would not recommend leaning on DNS to run Ansible, but it can be host names. And then you can categorize them. So in our giant Black Team inventory, we'll have like all the hosts listed out, right? That applies to all. Then each host will go as a child of either Linux or Windows or maybe router, whatever it is, because they obviously differ and you don't want to run Linux stuff on Windows VMs. So inventory helps you separate those out. And when you run an Ansible command, when you run Ansible playbook, you'll specify tac I and then the inventory file. And then you can even limit it to certain hosts in the inventory. As long as you create a good inventory file, you'll have a great time running Ansible. And then in terms of inventory as well, there will be variables that you can apply to those groups that you define. So there can be in-group vars. I would probably have like Linux variables, Linux-specific variables, because I want to say Linux connect with this type of connection, which is SSH, and then Linux connect with maybe this certain private key on this host. For Windows, Windows has a lot of variables. Again, I'm not as familiar with Windows, but you'll have differing things for those different groups. YAML, that's the one I'm more familiar with. I almost never use any type of inventories, but this is how they look. So in any inventory, you will have like brackets defining those groups. So in here, again, like I was saying, Windows and Linux are different types of groups in the inventory. And then you can also have web servers as like kind of like all web servers. And then this is mirrored on the right, but in a different format. So like I was saying, all means that everything, like if you run inventory with no restrictions, it will run it on all of those hosts. If you want to just run on Windows, Linux is a child of the hosts, or all. So it's just like different ways to define it. And then you can define variables inside of inventory, or you can define variables in its own variables file. It's very modular, and that kind of confused me in the beginning because I couldn't find a good example of like what a Linux playbook should, Ansible playbook should look like, because you really can mix and match the different methods. So for example, like I don't know where to put my variables, might as well separate it out. There's something called Ansible Galaxy that helps you set up those Ansible like structures for the files. And that was really useful because like, yeah, it gives you too much at times. Like it gives you group vars every single time. But it is really useful in setting up the structure so that you just have like a working Ansible playbook, and then you can change it however you want. So Ansible Galaxy, search it up. Useful inventory. I decided to add this because, again, usually you want to configure Ansible a little bit. And in the inventory file, the most important things are that you can make sure that you can connect to your managed hosts, right? The ones that you're running the Ansible on. So Ansible host, port, user, password are super important because you want to give it the correct username, password, SSH key, whatever, and type of connection. So like Ansible connection, SSH, or maybe WinRM or PSRP. I already went over this. To tell Ansible what to use. Otherwise, you will literally not be able to connect in. You won't be able to run your Ansible at all. Become and Ansible become method mean that, or end user, whatever, anything that says become means that it's escalating its privileges, right? Elevating its privileges. So in Linux, it would be the different methods are like su or sudo or whatever. Windows, it would be run as usually. And then sometimes you have different users that you want to become as, right? You have multiple administrative users, so you can specify which one to use. Maybe not specifically root. Maybe you have a different user that you want to use. And then on the right are also really useful ones. Ansible gather facts. I don't know why I'm going out of order, but Ansible gather facts is a useful one. It's a true or false one, so only 2 options. The default is true. So if you sometimes have Ansible tasks that don't need to gather facts, and gather facts is collecting information on the system that you're about to run that on. So if you want it to be like, if you want it to run a little faster and you don't need specific things like gather facts usually gathers like the operating system, right? In Linux, if you just cat etc os release, that's where it gets that information. You can tell it, no, I don't want you to gather facts, just run what I tell you. As long as it's not reliant on something where it needs to gather facts from, it runs your Ansible faster, which is cool. Python interpreter, that's a tricky one because it will complain about finding like a mismatched Python version on hosts, so that's a useful one. Common args for SSH, super useful as well. My favorite one there is TAC-O, strict host key checking equals no, because Ansible will yell at you that it, you know, it's like the whole like, oh, you might be man in the middle because the fingerprint changed on the host, especially if you're redeploying hosts a lot for competitions. And then private key file, you want to specify the like path to the key file that you want to use. Because if you have like multiple private keys on your host, you don't want it to default to the wrong one. Tasks, okay. So again, let's remember, Ansible has playbooks. Inside of playbooks are roles, and inside of roles are tasks. Tasks are, again, that single action. Add user XYZ. That's what a task is. And tasks use something called modules. So I just listed like some random modules there. Package is a good one, and you'll see an example in a couple slides about packages, because there's two different types of like modules. You know how I was talking about Terraform providers? This is sort of the same thing where there are built-in modules. So if it says ansible.builtin.package, or sometimes you can just say package without the ansible.builtin, that means that this is like a native Ansible thing. Or if it's from somewhere else, if it's like a community thing, it could say the thing underneath with the authorized key. That's not a built-in Ansible thing. So you have to define ansible.post. I don't actually know how to pronounce that. Define that whole string. So with the module, each module, same thing with Ansible, they have great documentation, so you can go and look up different Ansible modules. For example, look up Ansible built-in package, and you will have, they basically just scroll all the way down, ignore everything on the page, scroll all the way down, and you will see examples of using that module in a task. So modules basically allow you to abstract what the thing is. So if I'm running a command and it's like sudo apt install XYZ, package, all you have to do is say package, then you say the name of the package that you're installing, and then present like true. So literally, anyone can read this. They don't even need to understand the command line. They can just see that the package will be installed and the name of the package. I'm going to show it really quickly. So this is another built-in module. This is the user module. So the name, the first line there, is the name of the task. Oh, there's comments. This is great. The name of the task is to create admin users. It uses the module called user, and the user module, it asks for some things. So some things are required, some things are default, so you don't have to specify them. But at least you need to tell them what name you want for the user, right? And what password you want to set for the user. So in the user module, you'll say name, password, and then usually what group you want to add it to, what shell you want the user to use, and then yes or no if you want to create a home directory for that user. So this is obviously Linux, by the way. And then, like I did not get to on the last slide, their tasks can be run conditionally or in loops. So conditionally means like you'll have a task, and then at the end of it, you'll have something that says when, : and then, for example, the one that I use a lot is if the Ansible operating system is Red Hat, or if it's Debian, or if it's Ubuntu. That means that it gathered the facts, right? What I was talking about, gather facts. It takes the operating system, and then it stores it in that Ansible run. So then it can understand when or not to run a task. If I have a specific task that works on Ubuntu, but not FreeBSD, because those differ quite a bit, I can have a task that says when the operating system is Ubuntu. That's really useful. Or when you have some sort of variable to see if something was installed already, something like that. And then the loops for tasks, you use either like with items or loop. So in this example, I believe it uses with items. I think that's older. I think at this point you should be using loop, but I'm not too sure. I think either one will work really. And what this does is it loops over this user's like list, which is somewhere else. It's not in the screenshot. But you can also define it just like if you make a new line under with items, and then you have a bunch of like tags like under name, you can just like define the names of the users that you want to loop over. And then the when right here, item.admin means this was a variable defined somewhere else and is checking if it's defined or not. And then if it's not, or sorry, if it is, then you create those users that you loop over. Yeah. Roles. I don't know why we're going in this order, but remember, playbooks, roles, tasks. Roles group the tasks into a larger action. So, for example, installing Nginx could be a role, and then there are multiple steps that go into that, multiple commands you would have to run, so those would be individual tasks. And then roles, they are better because sometimes you'll want to use like a variable in a bunch of different tasks. For example, like, I don't know, that if you want a name for something and you want to have it throughout those tasks, you'll have it defined under the role. And then handlers, I haven't used those in a while, but those are also really useful. It is sort of like calling a function in a programming language, but do not think of Ansible as a programming language because you will like go down the wrong path doing like writing Ansible playbooks. Ansible is not a programming language, and don't try to treat it as such because it's not as easy as like defining variables and functions and stuff like that. It's more about the flow of what a playbook does. So, but having said that, handlers are similar to functions where you can call back to a handler and say like, if it's a repeated task, kind of like what functions are for in programming, you have a handler for that in Ansible. Yeah, this is, I can't really see that well. This is a bunch of roles in a directory. So essentially, this is kind of like the most that you could ever include in an Ansible role. I don't use many of these. I never I don't use variables that often in my separate file. I've never used library, meta, module utils, or lookup plugins, but templates are super useful. J2 means it's a Jinja 2 template, and that helps if you're like replacing a file or editing a file and you want it to be according to a certain template. You can search up Ansible Jinja, Jinja 2 templates. Same thing with files. So this files directory, you have to be very careful with the Ansible files module because a lot of times, like my Ansible playbooks, I'll want to like replace a file on a remote system, and I'll accidentally like move a file from my system to that one, which is not what I meant to do. You want to move the files from like right here in your files directory. If I want to move like bar.txt to like /home/Leah, then that would be like an Ansible task. Defaults are default variables. Variables are variables. Handlers, again, they can be defined in a separate file. I've never done that. I've just defined them in the same file as the playbook or like the role or the task. And then usually if you have a lot of tasks, you will separate them out into a tasks directory and have tasks like named different things. Like it wouldn't be named main.yaml. Usually it would be named something descriptive, like Linux deploy OpenVPN server, something like that. Or actually down there, Linux create users. And then we've gotten to the top level, an Ansible playbook. So this is when you have all your tasks, you have your tasks inside of your roles. Now you want to run that Ansible. What you're going to do is you're going to run the command ansible-playbook, and then you're going to specify your inventory file. It doesn't really matter what order you do these things in. TACI, inventory.yaml, and then you'll put the name of your playbook. So like when I do infra, I run the Ansible playbook that's called management.yaml. And what this does is it refers to all those roles. It refers to all the roles that have to do with like whatever I have to do for the management Ansible. If it's Linux, if it's the Linux Black team running Ansible, they're going to run linux.yaml, which is what we name it. It's very self-descriptive. And then what I was talking about with the grouping and the inventory file, if you remember, I'm not going to go all the way back to the slide, but if you remember, there was Linux and then there were hosts underneath it. If you want to restrict to those hosts, this is how you would do it. You would specify TAC-L for limit, and then you would say Linux. And then you would, if you want maybe all the Linux web servers, you would do Linux and web servers. Make sure to escape this with a backslash if you're using Linux or Linux adjacent command line, because and the exclamation point or bang are actual things in the command line. So if I was actually running this in my command line, I would do, for the Linux not web servers, I would do Linux : /bang web servers. These are really useful, again, because it's very modular, it's very Lego-like. You can say whatever you want, whatever group you define, you can run it at whatever time you want. And then this is an example of the top level playbook. So when I was describing, when I like made that off the dome, create users is an overall playbook. And then when it says host all, it's going to create those on all of the hosts defined in the inventory file. Then it's going to call the role Linux create users. So this is somewhere else. This is in the roles directory, and it's called Linux create users. And within that, it will have tasks, right? Same thing here with the install web server. It's going to run only on the hosts that are defined under web server and inventory. And then for the roles, it will deploy Nginx, and then it will deploy the actual website. Whatever that means, whatever tasks are inside of those roles, that's what goes under the install web server playbook. Variables, okay. I feel like I talked about this already. So I have not mentioned magic variables. These are variables that are set automatically. Again, the Ansible documentation is really, really good at explaining these things. There's just a lot of like, the big hump to get over is the different names for things. Like, as long as you remember playbook, role, task, then you can start maybe at the top, learn about playbooks, then keep moving on to like understand what goes into them, how to write a task, etc. It's all there. It's just like a lot, and it's kind of annoying because what like playbooks, roles, tasks, variables are all very specific things. If they don't fit in well, you won't have a working playbook, which is very frustrating. But I already explained playbooks. Group vars are variables for groups. This is like too much. Just like use variables for now. And then the inventory file, I've kind of gone through. I don't know why the slide is repeating itself. I kind of reused some slides. Ansible config. This is a good one. So you will have something called the Ansible config file, and it is named ansible.cfg. So on the left, I added something to talk about like what order of precedence Ansible takes when it uses those configuration settings. So first of all, before anything, when you run that Ansible command I was talking about, Ansible playbook, you can specify things at the command line while you run it, and it will ignore everything else in your Ansible files, and it will use that. I don't use that often because the whole point is that you're putting it in files, so you don't have to type out a giant command every time. The next thing it uses is the environment variable if you set it. So like when you in your command line, you say Ansible config equals, it will go and it will listen to that as the first thing. That's the first thing it checks. That's what it takes. I don't use this one often either. Then it will check the ansible.cfg file in your current directory. So when you're running Ansible, usually you want to just have a directory called Ansible and have all your files in there. That's where you would have your ansible.cfg file located at. That's what I use usually, and that's where you have, it's literally just like a blank file. You don't have to do anything crazy with it. All you do is write out, for example, like host key checking equals no, or whatever. Or forks equals 15. That's a super useful one. I'll get there. Then the next thing it checks is the Ansible config if it's in your home directory. And then finally, etc Ansible config. Basically, like these are just different locations you could have the Ansible config at. This could be really useful if, I don't know, you want to store different configurations and have really specific instances where you run them. Honestly, just use the Ansible config in your current directory. That's the one that it will default to, because you're not really going to set an environment variable. You're not really going to set a command line argument. So number 2 is the way to go. And then on the right, I wanted to include these because I was looking up, while I was making this presentation, I was looking up other Ansible configs because mine's usually not, like I don't have that many things in it. I'll have like forks, and I'll have things to optimize running Ansible. Forks means like, if you've been taking GSys, maybe you learned it in GSys. This is just like how many forks it creates to run Ansible faster. And then timeout would be usually for the SSH. If the SSH connection times out, tell it like after 1,200 seconds, oh my god. After 1,200 seconds, just give up because you don't want to hang forever. Host key checking, I mentioned that as an SSH argument. You can also define it in the config. Super useful so that it doesn't yell at you for man in the middling when you're not. And then a bunch of the cow things is what I found when I was looking this up. When I first started doing infra, I had no idea what Ansible was. I had no idea what Terraform was. I was learning everything from scratch. And the way that I remembered was Ansible was the one where the cow says the rules, and Terraform is not. Cow say is not an Ansible specific thing, but there are configurations that you can set. And then you can have a cow, or you can have other animals. If you set the I think the accept list, you can have different animals telling you things as your Ansible playwork runs, which is kind of cool. I will be using that. I think you need a little bit of fun and whimsy in your Ansible. So those are cool things to set in your Ansible config so that it runs with cowsay every single time. Or again, you can just run cowsay in the command line when you run your Ansible playbook. That's another option. And I don't know why I have another example, but there's another example of the overarching playbook. The playbook is called install Apache web server, right? Hosts all, again, it means all the hosts in the inventory file it's going to run on. It has become in here, which is useful. Become true, right? It's going to be true or false. It's going to try to run as the root user to do this because you need sudo to run sudo apt install, right? Because, foreshadowing, the tasks under this playbook are update apt Apache. Nope. Update apt cache. And then the equivalent of that little task on lines 6 through 8 is, what is it? Let me see. Sudo apt update, right? That's what you do before you upgrade or install things. So you're going to run sudo apt update. Then the install Apache 2 thing, all it does is it uses, when you see apt on line 11, for example, that is the Terraform, nope, not Terraform, Ansible module. So the apt module, all it asks for is the name, and then state present means install it, you want it to be there. I think the opposite of present is absent in Ansible, I'm not sure. Because I always just install things, I don't remove things. And the equivalent of the install Apache 2 task is sudo apt install Apache 2. And then the final one, ansible.builtin.systemd. This could also be on line 16. It could also just be systemd because Ansible built-in tells you that this is a built-in Ansible module. And what this does is it does systemctl enable Apache 2. Not enable, yeah, I'm lying. Systemctl start Apache 2. Personally, to this playbook, I would add enable Apache 2, right? Yo, I lied again. It actually starts and enables it. I give up, I'm tired. Any questions? No questions. Okay, I better see you all do the demo because I heard that it was using Terraform and Ansible to set up a, I don't know, instance or web server, so you can ask me questions about it. But yeah, have fun with the demo. Please sign up for Black Team. I hope you had fun.
Hi. All right. Demos today. So the stack is up finally as of last night, this morning. So if you do not have a stack account, you can use the Discord bot to create one. That information is in announcements. If you do have one, you should log in. If you forgot your password from last year, you can reset it with the Discord bot as well. For today, the first challenge is just to create an instance with OpenStack. It's not exactly straightforward, but it's not too complicated. So make an instance, and then after that, the last two are trickier. One is to write Terraform for OpenStack, and the other is to write Ansible for the Terraform for OpenStack. You don't necessarily have to run them, but you can run them using OpenStack. But you have to send them to me when you do them, and then if they're just good enough, then they're all good. Good luck.
Hello? Hi, guys. The pizza's here. Make sure to sign in.
need to memorize that or something?
No, I mean you should just like.
Hey guys, it's that time for research. Hi Casey. Hello. Hi guy. Oh, thank you. Thank you. What? What'd you do? Luca, please. You're ruining my research. Okay. Hi guys. Thanks for staying and coming and all that. Let's get into it. So if you're interested in presenting, make sure to fill out the form. The new form will be coming out momentarily, probably today. So that'll open up. There's lots of spots for spring semester. I don't have a ton yet scheduled for industry presenters. There will be stuff coming in soon though. So once that's up, I'll put an announcement out and let you know. As always, the blog is always up. If you're interested in making a blog post, fill out the form here, and we can work something out. You can get some points, win some prizes. And make sure to sign in if you haven't already. I'm sure you've already all signed in. Of course, join the Discord. Again, I'm sure you're all in that. And make sure to check out the calendar, calendar.ritsec.club, to see all of our events, as well as join the mailing list to get the weekly newsletter. Make sure to follow our social medias. And of course, please clap it up for the sponsors. Thank you. All right, to get into some announcements. So this wasn't mentioned in Adam, but in Adam's section, but I literally just sent out the announcement earlier. But next week, during the general meeting, that we will have the Bug Crowd Hardware Hackalong, which will be a event with Bug Crowd, replacing the entire general meeting, where we'll have hardware hacking. There'll be reverse engineering, working in a group, stuff like that. So it'll be a really cool hands-on event. So if you're interested, fill out this form. Yes, Leah? No, you do not. If you have no experience, that's fine. You can come and learn about hardware hacking. Yes, Garrett? Yes, there will be pizza. I pray and hope. Yes, limited spots, by the way. So fill it out. Yes, Leah? Yes, Casey will be helping out as a coach. Thank you, Casey. All right, moving on. Oh, yeah, so also I should mention, November 14th, next Friday, it's replacing the general meeting. There will also be a follow-up meeting on the 24th, which that'll be in the form as well to fill out, and that will go into more of the software, like reversing side of it. So anyone can do that portion. There's no hardware for that, so you can just show up. It's the Monday before Thanksgiving break. And if you have any questions, feel free to message me on Discord. Yeah, so ISTS Black Team signups have dropped. If you're interested, fill this out. ISTS will be coming up, sooner than you expect. So if you're interested, make sure to fill this out. Get on a team. WESIS, last call for challenge authors. If you're interested in being a challenge offer for the CTF CADE, fill that out. Challenges are due 11:10 at midnight. That's very soon. Junior Tech Lead application. If you're interested in becoming the tech lead in the future, make sure to fill this out, and you'll work with the tech lead to help make the weekly demos. As well as OT Security will have a guest talk by Christopher Cotter, Director of OT Security at Avangrid. So that's Air Gap, November 18th, 5 to 6 p.m. Make sure to pull up if you're interested. Now to get into some of the news, I'm going to be talking a bit about AI browser exploits with OpenAI's like Atlas browser and some of the other AI browsers, as well as Glassworm, which is a VS Code extension supply chain attack that recently dropped. So to get into it, AI browsers are like kind of becoming a thing. If you don't know anything about them, they're kind of just like shove ChatGPT everywhere in your browser, and it can do things for you, ask it questions, it can like navigate a bunch of stuff like that. And so some researchers recently have like discovered that because of how these browsers work, you can essentially like inject commands to the LLMs, but it's essentially like CSRF, like cross-site like forging, and that lets you sort of just like dump like commands through like hidden text or whatever. And some examples they gave were like Reddit, if you like spoiler a message and then the LLM were to like read through the page, you can essentially like inject prompts into the large language model, which can then access stuff like your whatever, like personal information through emails and stuff like that. So it's not like something that's actually been exploited. I don't think researchers didn't really mention that, but they have found like multiple of these exploits do work against some of these AI browsers. And here's like a little bit of a layout that they described, where essentially like you'll go to like a compromised web page, and then it'll essentially like piggyback off the AI and like inject a prompt, and then because of how like the persistent memory works, that can be stored to like the LLM's memory, and it will continue to have like those malicious prompts. So it's a bit of an interesting thing that was kind of talked about recently, or like a few months ago when we had the other bug crowd presenter talking about LLM hacking. So it's kind of cool to see it actually like coming into fruition. Next up, Glassworm. This is a VS Code supply chain attack discovered by Koi Security. It's a worm essentially that was just like put out through some extensions. There's a variety of extensions. I'll go into some more of the details, but essentially it's just like I don't know, like I wouldn't say basic, but it's a worm, and it uses some like kind of crazy things. It uses like a blockchain and also Google Calendar for C2. So like here's like one of the blockchain like wallet requests or whatever, a transaction, and essentially it uses like encoding like in the memos to reference like the C2 server itself. And here's also the Google Calendar, which is kind of crazy. I don't know who the heck comes up with Google Calendar for like C2 persistence, but they use like I don't know, some kind of crazy stuff like that. Like let me actually like hold on. If I like go back real quick, if we pull up CyberChef and actually just like look at the name of this event, like we can just go in here and see. Like there you go, leads to an IP address and whatever where they're fetching their payload from. So it's kind of crazy persistence that they're using through that. If you go to the event right now, it's like gone, but it is like kind of smart to use these things for C2 persistence, because like with these blockchain transactions, like you can't exactly just like get rid of them, because I don't know a ton about how blockchain works, but they're kind of just like persistent, which is kind of crazy how someone came up with stuff like that. Some other things, here's like one of the like a JavaScript for some of the extensions, and they use like I've seen like this trick used before, but essentially using like Unicode characters to try and obscure the source code by like literally just physically hiding stuff like really far down. You can see there's actually like malicious code or whatever. I mean, it's not malicious, but whatever the malicious code is like sort of obscured by doing stuff like that. This is like some of the effects quoted by the researchers. They said essentially harvest npm, GitHub credentials, stuff like that. Deploy like proxy servers, installed stuff. Essentially, it's kind of just another like wallet grabber. Also, I don't think this would really affect pretty much anyone here, because if you take a look, this is one of the extensions that was affected in VS Code. So as long as you're not like installing random sketchy extensions on VS Code, you're fine. But it still is interesting that this stuff can sort of spread through official avenues in something like VS Code extensions. There's my sources. And now, without further ado, to get into the presentations, first up we have John Godman with Zero Trust Architectures.
Hey, 1, 2. All right. So, hey everybody. So my name is John, and this is going to be a presentation on zero trust architectures. So first, quick little what we'll be going over. First, we're going to do a little intro. Then, what actually is zero trust? A little explanation and some brief history. Then the components of zero trust systems. So we'll talk about these later. How it's actually implemented and what does that actually mean. And just feel free to stop and ask questions. I'd ask that you raise your hand, but I don't really care. And note that a lot of this is really higher level stuff, but if you want to go more in depth, feel free to talk to me. Okay, so quick little who am I? I'm not going to go over any of these, but if you see something interesting, come talk to me. Actual importance, though, is my work with NIST and their National Cybersecurity Center of Excellence, which is where I worked on the Zero Trust project, which is where I learned all this, and I'll talk about that later. Okay, so what actually is Zero Trust? Well, put simply, it is zero implicit trust granted based on network location. Pretty simple, right? Well, what does that actually mean? Well, in order to understand that, we need to look at the old guard of network security, which is the perimeter model. So this is the traditional model. The basic understanding, oversimplified, is that everything inside is good and everything outside is bad. And this can lead to some obvious problems. Again, this is quite oversimplified, but if you have a perimeter with an asset and you have a bad actor, let's say that bad actor gets inside your perimeter. Well, now you're screwed. It's game over. There's nothing stopping the attacker from moving laterally across the network, meaning from asset to asset. Again, this is quite of an oversimplification, but if this were to happen, you'd be in trouble. So how can we actually solve this problem? So enter the zero trust strategy. So the idea behind zero trust is the protection of subjects, which are human users. So that's could be humans or service-to-service communication or other clients, and resources, which are the actual data, applications, infrastructure, et cetera, that you're securing. So instead of the whole network, Zero Trust focuses on a per-access-based request from subject to resource. And the key part of Zero Trust is the assumption that an attacker has already breached your perimeter. And so you already have an attacker inside your network. We'll see later how this comes in hand. But just assuming that that first layer of defense is broken is key to the design of Zero Trust architectures and the components that they used. So these architectures are split up logically by the control and data planes, as well as the untrusted and implicit trust zones, which we'll see later. This is typically done using logical network separation, like VLANs, but there are definitely other ways to do it. I won't touch into because they can get pretty complicated. But as you see in this example, we have a human subject trying to access a GitLab server with the policy decision point / PEP in the middle that I'll talk about later. So our human, in a zero trust environment, our human will talk to that, and that will talk to the resource. Pretty simple, right? Well, let's take a little closer look at this. So firstly, what is this policy decision point? Well, it's actually made up of several components, mainly the policy engine and the policy administrator. And the element between our subject and resource here is actually called the policy enforcement point, which bridges the gap between the control and data planes, and it will actually allow us to talk to our resource. So we'll talk more about each of these components later. But first, we just want to understand that these policy decision point resources are located in the control plane, whereas the subject, resource, and the policy enforcement point are located in the data plane. And we can also split up the data plane based on our untrusted zone and our implicit trust zone. So the general idea is keeping everything in our subject untrusted, and then only the actual resource and the policy enforcement are trusted. So to define further, specifically from NIST Special Publication 800-207, this is the operational definition of Zero Trust. It's pretty long, but the key points are that Zero Trust enforces least privilege access per request, and that this architecture is comprised of the components, workflow, and the access policies. and we can define a zero trust enterprise by its network infrastructure and operational policies that are in place to actually implement zero trust. And as a last bit of prerequisite information here, some brief history. So the term zero trust was coined by Dr. Stephen Paul Marsh in his 1994 doctoral thesis, discussing trust as it relates to computation. And in the late 90s and early noughties, we started to look closer at the existing perimeter model and actually talk about, hey, why this is probably not the best. And in response to I believe it was a Chinese cyber attack in 2009, Google published the Beyond Court papers, which outlined the basis of zero trust security that they implemented as a response. But it wasn't actually called that. In 2010, the Forrester zero trust paper published by John Kindervag first actually started using the term zero trust in the context we know it today. And then most recently, zero trust was standardized in NIST's SP 800-207. And in 2018, the implementation guideline was written by the NCCOE. The standardized in 2018, and the implementation guideline was finalized in 2025 as SP 1800-35. So the core concepts of zero trust are not very new in the relative history of cybersecurity, but the implementation and standardization are still quite young. All right, so now let's go a little more in depth on the actual components that make up a zero trust architecture. Firstly is that policy decision point, or PDP. No, it's not a DEC computer. As mentioned previously, the PDP is made up of two components, the policy engine, or PE, which actually makes the decisions per request, and the policy administrator, or PA, which is responsible for making and breaking the connections between subjects and resources. Again, they are usually combined into one singular piece of software that provides both logical functions. But overall, you can think of the PDP as the judge, jury, and executioner. So as I said, the policy engine, the PE, is the ultimate decision maker, acting as the judge/jury. And it does this with a trust algorithm. Now, there's a lot of different variations of trust algorithms that I'm not going to get into the nuances here, but the basic idea is there are two main differentiators, and that's criteria-based versus score-based, and singular versus contextual. So, I'm sorry, let me click on the wrong button. So, criteria-based algorithms assume a set of qualifications that must be met to grant a request. So you have to have X many. Like you think of it like a checklist, right? You're checking down each thing. So once you've met a certain number of checkboxes, you're good. Whereas score-based algorithms will compute a confidence score through the predetermined weights that are set. So you have a weighting for each item, and that when that score meets a certain threshold, it's granted. And then singular versus contextual trust algorithms describe the ability of the trust algorithm to consider multiple requests at the same time. A singular trust algorithm, of course, can only look at one request at the same time, whereas a contextual can look at multiple at the same time. But regardless of the trust algorithm being used, they are all influenced by the written policy and the data from PIPs, which I'll discuss later. Of course, the PE logs its decisions, which it can then use later as more input data. And it's given requests from the PEP, and it sends those requests from the PA to execute. So again, you can think of it as the judge/jury in this like courtroom model. So next is the policy administrator. As I discussed, it manages connections between subjects and resources. Specifically, it commands the individual PEPs. The PA can generate session authentication tokens or other means of session authentication, and it communicates with the PEP on the control plane. You can think of the PA as the bailiff in this courtroom analogy, and as previously mentioned, it's most commonly combined with the PE to form a singular PDP product. So again, you can think of that as the bailiff. So circling back a little, as I said, the policy information points, or PIP, are the actual input data that's fed into a trust algorithm. to make these request decisions. Now, this input data can be from a lot of different things, depending on the trust algorithm. For instance, can be from a continuous diagnostics and mitigation system, or a CDM system. It can be industry compliance. It could be from a threat intelligence feed. It could be from network and system activities log, data access policies, public key infrastructure system, an identity credential access management system, or ICAM, a SIM, or security information and event management system, many, many others. There's a lot of different data that you can pump into one of these trust algorithms, depending on your trust algorithm, and you can use all sorts of data to feed that decision. So lastly, we have this policy enforcement point, or PEP. So the PEPs enable, monitor, and terminate the connections between subjects and resources. So they are the connection between the data and control plane. The PEPs, a lot like the trust algorithms, can have many different arrangements and architectures themselves. For instance, they can be more of a client resource model, where the PEP sits directly in front of the resource, and that client has like an endpoint agent on it. Or they can act more as a gateway portal, where the PEP is its own entity that sits in between the subject and resource. There's a lot of different configurations, all with their own benefits and specifications, and it really depends on the scenario for that resource and subject. Theoretically, you can have all different kinds of PEPs in one system, although typically you only really see one kind per enterprise. As previously mentioned, they have an implicit trust zone, so that the PEP can actually interact with the resource. And remember that we're using least privilege access for the client, which doesn't restrict us from having that implicit trust necessary to communicate with the resource in the first place. And you can kind of think of these guys as the gate guard, kind of in that courtroom analogy. But there's, for each resource, you'll have a PEP. All right, so now let's talk about how we can actually implement these components and tenants into the system. So you might be thinking, what do we actually do? Well, this is where the tricky part comes in. So there's a few inherent issues with implementing Zero Trust that make it a little difficult. Firstly, there is no one product solution to make your enterprise a Zero Trust architecture. You have to have a lot of different products working together, a lot of moving parts in one machine. It also requires full organizational support. You can't really transition part of an organization to Zero Trust without the whole organization. Now, granted, that's easier if you're building Zero Trust from the ground up, but you still need the whole organization on board. Furthermore, it requires a foundational organizational structure. Again, a lot easier if you're building from the ground up, but if you've got an existing system, you have to have these network and resource structures built for Zero Trust. And lastly, and hopefully what this presentation can help with, is that the lack of common understanding of Zero Trust topics. One big problem is that a lot of people just don't really know about Zero Trust. Maybe you've heard of it, and maybe you think it's something that you can only really implement on a really large scale, like with a giant government organization. But hopefully, in talking about Zero Trust and the more recent publications from NIST, as well as the increasing availability of Zero Trust tools, that problem can be solved. Now, one thing that might have caught your eye, if you've ever done, well, really anything with IT, is that requiring multiple products working together is an absolute nightmare. And yes, it certainly can be. I'd say this is where the bulk of difficulty in building Zero Trust environments comes from. However, like Leah and everyone else was talking about earlier today, one thing that really helps that I personally found to help is a lot of those infrastructure as code tools like Terraform and Ansible. At NIST, I did a lot of working using these tools to spin up and scale lab environments. Sadly, I can't share any of that work, but it certainly helped me learn just how powerful these kind of tools can be in deploying these large, complicated systems. But anyway. All right, so what do I actually do if I want to create a Zero Trust architecture or transition my environment to Zero Trust? Well, our first step, like many security processes, like risk management, is to analyze our current state. Now, if you're starting from scratch or migrating in an existing environment, this might look a little different. However, the core step remains that we need to actually identify the assets that we have that actually need protecting, what our subjects are, and how resources are utilized. If we're migrating an existing environment, we need to review our current access policy. So what do I, a user, need to do if I want to access a resource? If we're starting from scratch, we still have to look at this. How will our resources need to be accessed? So then we actually need to create this new access policy. And in a zero trust environment, of course, we need to do so while conforming to the principles of least privilege and separation of duties. Access policies should be created to authorize subjects with least privileges required to perform their tasks on a resource that they are permitted to access. Basic stuff, but it can get a little complicated with zero trust. There's a few things that you should consider that you might overlook normally. So consider this following example, right? Let's say we are an organization based in the US, and we get a request from a client originating from Belarus at 3 in the morning, attempting to access an important document. Now, obviously, this is typically something that would raise some alarm bells, but maybe our organization has contractors in Belarus who are logging in at lunchtime in their country and performing their work they're supposed to be doing. Now, while this is a scenario we might analyze normally in a security context, the key things that we have to look at here are location, time, the asset itself. All of these can be used to help create a better policy. While a lot of the power from zero trust architectures comes from that trust algorithm's ability to take in a lot of different information and make a decision, if it doesn't have a baseline to go off of, it's not as powerful. So we need to make sure we're writing good policy. All right, so continuing on, now we can actually start to implement some software. So first and foremost, we need to make sure that we have the tools to support our zero trust components. So this includes security tools like SIMs and vulnerability scanners, but it also includes the underlying infrastructure like our ICAM system to provide user information, among other things, as well as multi-factor authentication and endpoint protection. These components are crucial to the functionality of our zero trust components, not only providing information in the form of PIPs, but actually supporting that system. So now we can actually start to implement our zero trust components. So of course we're going to need a PDP, and there are many, many options to choose from open source solutions to paid cloud services. Then of course we need a PEP to actually support our resources. As mentioned previously, there's a lot of configurations these PEPs can operate in, and naturally there's a lot of options. Lastly, it's important to note that our ZTA must evolve over time. Oh, I'm sorry, I've missed one. It's also important that we can actually integrate all of our applications with our products. So that's something we need to take into account. So it's important that our ZTA evolves over time. We can't just implement a few pieces of software and forget about it. In order to maintain the best security, we have to continuously reevaluate our zero trust environment and configure and possibly change or upgrade components. So you can see it's a large endeavor. As I said, there were a lot of options. Well, how do we actually choose what option is right for us? Well, Special Publication 800-207 outlines these questions for choosing components. And I paraphrased them slightly, but they essentially ask the following. Firstly, does the solution require components to be installed on the client asset? Well, this is important to consider if we're using non-enterprise owned assets, like in a bring your own device office setting where workers, employees are bringing their own laptops to use. Secondly, will the solution work for both our on-prem and cloud infrastructure, or both? Some solutions are cloud-based, while some are on-premises based, and depending on the structure of our assets and infrastructure, this can be a very important consideration. Next, does the solution log interactions for analysis? Obviously, this is a key principle of zero trust. We need to be able to collect data and feed it back into that policy engine. Next, does the solution provide broad support for different applications, services, and protocols? And again, obviously, depending on the assets in our network, this can be crucial. Some products will only work on like the web plane, and while that might be perfect for one enterprise, it might be completely useless for another. And lastly, does the solution require a change in behavior for a subject? Now, this is a critical one and could realistically be a whole nother presentation in and of itself. Additional security will often require additional or different behaviors from our users/subjects. And there can be a limit where users get so annoyed from having to do these additional steps that they might start to forego our controls entirely or just not be able to work to their full potential. So there's a balance between security and usability that we need to consider that's crucial for these solutions that might drastically change the behavior of our user. And I put some little examples here. You might have heard of some of these companies like Zscaler or Okta or AppGate. Lookout, Ping Identity, that is the Microsoft Entra ID logo. It used to be called Azure AD, but they changed it to Entra. Same thing. and IBM Security. These are just a few of the many companies that offer zero trust solutions. And again, while they all offer different parts of the zero trust, there is no one product that you can just say, all right, I want that, give me zero trust. All right, so we've got our zero trust components deployed in our environment. Well, what does this actually mean? Well, let's go back to our earlier perimeter example, this time with the ZTA components in place. So if we have our asset in the data plane here, and our bad actor comes up wanting access, they're going to be stopped by our PEP. Let's say for this example, it's a portal configuration, so the subject will ask the PEP for access to our asset and present relevant information about the request. Our PEP will then go to our PDP and provide it with all the information it has about the request. And the PDP will then make a decision using data from its written policy, its ICANN systems, logs, the SIM system, CDM system, whatever, right? And it has two decisions it can make. Firstly, it can say, okay, cool, let them through and approve the request, or it can say, no, go away, and deny the request, right? If our request is denied, our PEP portal will block the request for access, and policy might prevent our subject from further requests for a period of time, depending on our trust algorithm. We could do a lot with that. But let's say for whatever reason that the request was approved. Maybe our bad actor is an insider threat that should have access to this asset. Well, even if they were to gain access to the asset, they're of course going to want to move laterally and gain access to other assets on the system. Well, here's where the beauty of zero trust comes in. Because our access is per request, the bad actor cannot move laterally, and they are stuck. And our bad actor is now sad. They have failed. Okay, so what are some of the benefits of using a system like this? Well, firstly, we have a much more secure access control. Access is granted based on strict authentication and authorization checks, regardless of network location. Secondly, zero trust allows us to operate contextually, taking into account information from all over the system for each request. While some trust algorithms might not operate contextually, it gives us this opportunity to do this. Next, zero trust systems continuously evaluate access and applies policy in real time throughout a session, which ensures that even after access is granted, it's continuously verified. Zero trust also allows us to protect these hybrid systems, consisting of resources both on premises and in the cloud. And again, regardless of network location, which can be really powerful if you have a really complex hybrid architecture. Zero trust can also, I didn't click the button, I'm sorry. Zero trust can also protect an organization from external threats. So let's say if we're working with another organization on a project, well, that organization's security is out of our control. But we can ensure that our resources remain secure. Zero trust also gives us secure sessions for data transfer, ensuring that data in motion is secure as well. So you might think, okay, perfect, shut up and take my money, right? Well, of course, with all these benefits, there are potential threats. These specific threats were outlined in SP 800-207, some of which are a little outdated, some of which have changed, but all of which still remain. So firstly is the subversion of the trust algorithm. So if an attacker were to compromise the policy engine or policy administrator, they could, of course, disrupt operations or grant unauthorized access. Obviously, that's a big problem, so we need to make sure that those are secured very well. Subsequently, attacks on the PE or PA can result in denial of service or network disruption in general. However, redundant or resilient PE/PA systems can help to mitigate that risk. Next, while encrypted traffic may be practically useless to traditional monitoring tools, having all of your data under one roof can aid in the analysis of data using things like machine learning to flag traffic patterns. Next, the information on our systems and network can be a big target for attackers. So it must be tightly protected. Knowing how our zero trust system is built can be a big target for an attacker. Of personal importance to me is the resilience on proprietary data formats or solutions that some zero trust solutions require. Vendor lock-in is a big problem in the field and an existing problem identified by 800-207. It's something that is getting better, but since there are so many different components that go into these zero trust systems, it's difficult to write one standard or one protocol that covers all bases for everything you need. So vendor lock-in is still a pretty big problem. Lastly, automated systems like AI administering zero trust systems can leave the whole system vulnerable to weaker authentication mechanisms or social engineering. In general, highlighting the problems of AI managed security. Um, so, obviously, there are some problems, but personally, to conclude, here's my 2 cents. Of course, take this with a grain of salt. I'm a student, and those who know me well will know the other reasons. But personally, I believe that a properly implemented zero trust architecture greatly reduces the overall risk to an organizations. And of course, I say properly implemented because while it's difficult to set up and maintain these systems, I believe it's definitely worth it in the long run. Of course, as everything with security, there is a lot to be done in the field to enhance these solutions, tenants, and tools. It's a lot of work. We get a lot of work to be done. But I think right now, they're in a pretty interesting state to learn about. So I briefly mentioned I learned about all this while working on the Zero Trust project at the NCCOE. I'd like to thank my colleagues there for teaching me a lot of this and helping me learn everything else. And I'd like to thank you all for your time. So here are my sources. If you're interested, that first one is the one that I worked on with the NCCOE. A lot of the funny black and white illustrations came from the last one. So yeah, that's it.
Is there any questions? I mean, do you want to stay and
Oh, yeah.
questions? And
Questions?
People have any?
Yes.
Can you clarify the difference between the PDP and the PEP?
Yeah, of course. So the major. Oh yeah. The question was, can you clarify the difference between the PDP and the PEP? So the major difference is that policy decision point lives in the control plane, and the policy enforcement point lives in the data plane, right? So the policy enforcement point is the entity that you're actually dealing with from a user and resource perspective, right? The users aren't going to be talking directly to the policy engine. They're not going to be talking directly to the policy administrator. They're talking to that policy enforcement point, right? You can think of it like a gate guard, right? If you go up to a gate at a facility, you're not going to get on the phone with the CEO and ask if you can come in. You're going to talk to the gate guard. The gate guard's going to talk to his boss or their boss and ask, okay, can this person come in, right? And they're going to make that decision. The PEP doesn't make any decisions. It only allows that connection. And that can be done through many ways. It can be done through a simple tunnel. It can be done through microsegmentation in the network. It can be done through other tunneling methods. There's a lot of ways you can do that. But the general idea is that you, the subject, are talking with the PEP, and that PEP talks to the PDP to actually confirm your request. Any other questions? All right. Oh, yes. I don't know what I would do. Yay! Thank you.
Testing. Hello, everyone. I'm here to talk to you today about cryptography. But first, who am I and how did I get in your house? I am Joseph Isaac. I'm a third-year cybersecurity and software engineering major here at RIT. And the reason that I'm talking to you about cryptography is this summer I was thinking of what I wanted to do for an honors option. For people who don't know, that's basically just a project that extends a course in some way. And I wanted to do something that I liked doing. And I've done work as in web application reviewing, looking through like security, doing static and dynamic analysis. And one of my favorite things to do, and oops, did I change tabs? Never mind, it's just being slow. Okay, it'll change eventually. Okay, one of my favorite things to do is break into websites. And there's a lot of ways you can do that. You can use Nmap to scan for open ports. You can use Burp Suite to look for vulnerabilities or access data that you're not supposed to. If it's a really poorly designed website, you can try and SQL inject or buffer overflow if it's really old, I guess. But then in terms of cryptography, how do I break into this? Let's say I don't have the key. What do I do with this? This is just numbers. What do I do about this? You can't decompile it. I tried. I put it in Ghidra. Apparently that's not how that works. That didn't help at all. So what do we do to break into cryptography and break encryption? Well, I'm going to talk about that today. I'm going to go through some of the practical ways that cryptography can be insecure. I'm going to go through some demos, some examples, and some real-world case studies and some statistics that I found interesting about it. But first, what is cryptography? I'm going to assume you all have a pretty good understanding of what it is if you're in RITSEC. But for the one confused humanities major in the room, cryptography is math that controls who learns what. Since the beginning of forever, some people have had information that they didn't want other people to have, so we came up with ways to hide it. One of the earliest ways we did this was the Caesar cipher. This was in 58 BCE. I'm sure you all know this. You all had to program this in your introductory programming courses, I think. I certainly did. That was fun. But as computers got better and people learned how to read and write, that wasn't very good because you can break that on a piece of paper in like 5 minutes if you wanted to. So one of the first mainly used algorithms was DES in 1977. And we used that for a pretty good time before evolving onto AES, which is what I'm going to spend a lot of time talking about today. But even today, with the advent of quantum technologies, we're still making new algorithms. So on the left there, you can see a diagram of kyber dilithium, which is a post-quantum resistant algorithm. But we're going to talk about AES. So I love AES. AES is the backbone of modern symmetric cryptography. You'll notice that I said symmetric cryptography. This is opposed to asymmetric cryptography. Asymmetric cryptography is different from symmetric cryptography in that symmetric cryptography has one key, use that to encrypt and decrypt. Whereas asymmetric cryptography, you can have a public key to encrypt something, and then you can't decrypt it with that. You need the private key to decrypt it. Very interesting. It poses a lot of interesting security challenges if you're using asymmetric cryptography. But unfortunately, I don't have time to talk about that today, and it's kind of out of scope. But symmetric cryptography is still pretty cool. So AES has a 128-bit block. It has variable keys from lengths of 128 to 256 bits. Depending on which key length you use, it affects the security of it. So it'll do more rounds if you have a larger key, and it makes it really secure. And it's used absolutely everywhere. It's embedded across the stack in the browsers. It's used in TLS handshakes since version 1.2, I believe. It's used in enterprise VPNs to encrypt your traffic. It's used in Wi-Fi, WPA, Wi-Fi protected access. It's also used in disk encryption as well. So if you have bought a disk drive, it's highly likely that it's using a modified version of AES called AES XTS to encrypt your data to make it harder to get to. But don't just take my word for it. Why don't we do a little demo? I'm going to take a picture of myself and I'm going to encrypt it because why not? You probably shouldn't trust me. I'm a random person. You don't know if I'm lying to you or not. So I'm going to send that to myself. So give me just a sec. AES was also invented by 2 people. They were fighting against like IBM in their contest, and they won. They did a really good job. It's very impressive. Just give me a sec. I need to switch my screen. Okay, perfect. So, reload from disk. You can see our image right here. Wow, isn't that a great photo of me? Wonderful. I need to refactor these work. Okay. So now we're just going to encrypt this using AES, and AES is really secure, so this should look really good when I do that. So I'm going to do that. I'm going to get the output. And now, as you can see, here is our original picture, and as you can see, it is perfectly encrypted, and there's absolutely no data that has leaked at all. Oh, well, that's strange. Why did that happen? Why can you see the outline of my face here? That doesn't look very secure. We're leaking patterns. Why is that happening? It's almost like I planned for this. Hold on, I have to reshare my presentation. Give me a sec. This is very... I was expecting to have another monitor, but whatever, that's fine. Mozilla Firefox. Allow, thank you. Thank you for your patience. Cool. In order to understand why this is happening, we need to talk about block cipher modes of operation. What is a block cipher mode of operation, you might ask? Well, if you recall, I mentioned that AES was had a 128-bit block size. What does that mean? Well, a 128-bit block size means that it processes 128 bits of information every time the cipher runs. That's actually pretty good compared to the older algorithms, which didn't do as many. But unfortunately, you generally are going to have a lot more than 128 bits of information. The image that I just showed was several megabytes. So you have to run it through the cipher multiple times. So you need rules to tell the encryption algorithm how to put all of it together. So the simplest way you can do this is you can just run each block in parallel. You throw it through the cipher with the same key. There's more advanced versions like cipher blockchaining mode, where you start with a initialization vector, which is just a piece of data that you throw in and XOR with the plain text, and then you throw it through the cipher, and then you take the output of that, and that becomes the initialization vector for the next block, effectively changing the output in all of them. There's also one more mode I want to bring up, which I'm going to talk about in a bit, called counter mode. Counter mode's a bit different in that you don't actually put the plain text through the cipher itself. You take a nonce and you take a counter and you concatenate them, and you put them into the cipher with the key, and then you take the output of the cipher, and then you XOR that with the plain text. The plain text never actually goes through the cipher. And all of this determines the parallelism, the leakage, the integrity of the message. There's also some block cipher modes of operation that don't just offer confidentiality, but also authentication. For instance, Galop counter mode. That takes an authentication data and then throws out an authentication tag at the end to make sure your data hasn't been tampered with at the end. And that uses CTR. So in the case of our image, what we used was ECB. ECB is really bad. You don't ever want to be using ECB. Why is that? Well, it's deterministic. It leaks patterns when it's used. So when you use ECB, the ciphertext output is always going to be the same if the plaintext input is the same. That's not good, because as you can see in this checkerbox example, and the example of my selfie, it preserved the structures. Different colors and things show up in the visual. There's no indistinguishability under a chosen plaintext attack. And you can just you can make out patterns in not just images, but also text. So let's take a text example. Well, let's say through ethically and legal means you've come into a bunch of passwords and you happen to have some hints or context as to what they are. What are you going to do to figure out what the passwords are? Well, the first thing you can do is you can just sort them by the ciphertext. If you have any sort of context for what the password is, or you can just try really common passwords, you can then try and crack them one at a time, or just try and crack the most common ones. In this case, you can see that there are lots of hints mentioned, 6 digits or ATM or PIN or whatever. You can just try 1, 2, 3, 4, 5, 6. Once you have one of the ciphertexts that is corresponding to that password, you have all of the ciphertexts. And passwords are generally pretty short. They're usually within one block. I think AES would contain roughly, 16 digits or so of data. So if you have a longer password than that, and it starts with a, let's say someone else changed their password to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 or so, and their password is still going to start with 1, 2, 3, 4, 5, 6. Even though it's a different password, the ciphertext of that password in ECB mode is going to start with the same ciphertext. It's going to still start with AF, or 8F, 4A, 13C9, etc. But this is a really simplified example. There's no chance that anyone would do this in real life. This would never happen whatsoever. This has never happened before. No, I was lying. This has happened multiple times. If you thought the example I just gave was too simplified and wouldn't ever happen, it did happen. This is exactly what Adobe did. They encrypted passwords and stored hints in plain text along with them. which, if you know anything about authentication, is not how you're supposed to do that. You're supposed to hash the passwords. But you know, just an Adobe moment. They're great. Hey, so why does this happen? Why do people use ECB? Well, some of it's just like ergonomics and inertia. In a lot of like languages and encryption functions, ECB is just straight up the default. If you try and encrypt something, it's going to use ECB since it's really simple and easy to use. It's just going to default to it. You don't need an initialization vector or anything. It just works. Unfortunately, it just really sucks. There's also a established industry practice of just reusing old code, and cryptographic security principles weren't as always as high of a priority. So people would just copy and paste old code, and that would just get put into production with insecurities. And this is a pretty common issue. This is an older study from 2013 about Android apps, where they found that 65% of apps that used some form of cryptography had used ECB. This statistic has changed a little bit since it's been a while, but the statistic is still roughly the same. I believe it's around 61% now if you're factoring in transitive libraries. Because even if you don't use ECB, if you import a library or a function or framework or whatever that does use cryptography and uses ECB, you've just created an insecure app. So that's really cool. And lastly, legacy firmware, like hardware that uses this, have really long cycles. So you might make a really cool app that you make sure is really secure. You audit all of your dependencies and make sure there's absolutely no ECB inside of them. But oh no, the router in your home uses ECB, which was an issue that existed in 2023. Oops. So that's really cool. So how do we fix this? Just don't use ECB. There's not really much of a reason to. It should honestly be banned. I don't know why so many encryption algorithms default to it. It's basically not encrypting anything. That's not true, but it's not good. Ideally, linters and the like should be updated to identify it as a vulnerability because it's technically being encrypted. It's just not good encryption. If you need determinism for whatever reason, you shouldn't be using ECB. You should be hashing or tokenizing things. Don't use ECB. If you're building a really big app, be sure to look into the encryption algorithms that you're using. I know that it's easy to just use something and trust that it works, but you should actually look into those. And lastly, you could just use a different block cipher mode of operation. Ideally, one that uses nonces and IVs. Yes. So, nonces and IVs. We've fixed everything, right? If you use one of those, everything's great, right? Well, maybe. So, what is an IV? Like I said on the block cipher mode of operation slide, an IV is basically just a string of data that you feed into the cipher or to try and make it more random, to change the output. So there was cipher blockchaining mode and there was CTR mode. It makes each the encryption fresh. It's very nice. And it's not a secret. Like, this isn't like, you don't need to store the IV like secretly. It's oftentimes transmitted along with the message. So why is it such a problem if you reuse it? Well, let's take CTR for example. It becomes a problem since if you're using the same initialization vector in a mode like this, it means that the key stream is going to be the same for both for any encrypted plaintexts. That means that if you XOR the ciphertexts or the outputs of the cipher, it's going to have the same output as XORing the plaintexts. This also exists in other like encryption algorithms like GCM or ecliptic curve digital signature algorithms. They can cause you to recover the public key, but we're going to focus on CTR. So that's a lot of jargon I just threw at you, so maybe an example will help you understand. So I'm going to take another photo of myself, because I'm looking great today. Send that to myself, just so you know that I'm not cheating. Okay. Please hold. Second photo, wonderful. Okay, assets, test 2. Okay. So we're going to run through using the CTR algorithm as if using the CTR algorithm with the same encryption initialization vector. So we're going to start by generating an initialization vector. So I'm going to do that real quick. Get you an example of that. Okay. Outputs. So as you can see, this is our noise. This is a visual representation of a pseudo-random number. This is what we're going to be feeding into the cipher along with the key. and this is, this is the output of that, rather. My apologies. And this is what we're going to be zoring with each of our images. Since all that CTR mode is it takes in an initialization vector and the key, throws it through the cipher, and then zors that with the plain text. So now let's zor that with one of our images. So we're going to do that. So now, as you can see, our original image has vanished in the noise. That said, it's still in the noise there somewhere. It's kind of hard to see in the PyCharm example, but if you look in the static example I've seen where I encrypted Tux the penguin, you can actually see the outline of the penguin. Oops, goddammit, it's lagging. Kind of hard to see. You can see the outline of the penguin within the noise. I don't know if you guys can see that. Yeah, you can see it. Okay, cool. So you can see, that'll be relevant in just a moment when we encrypt another image with the exact same noise. So I'm going to do that real quick. Slow on the trackpad. That. So now we have our second image. And like the other image, this second image possesses these same traits. You can still see the pattern within the noise. This is a problem because now we can, if you have access to both of these ciphertexts, you can zor them together. Because the noise is the same for both of these images, if you zor it together, it's just going to cancel out the noise. Meaning that the output is just going to be the two images that are zored together. So if we do that right now, it's going to do something. Reload. And then, as you can see, it looks like two images zored on top of each other. Now, we're not fully there yet. You can see, but you can clearly see some of the information has been recovered at this point. Right? You can see both of the images layered on top of each other. And if you have access to one of the images, that means that you can zor this output with the original plaintext, or the original image rather, and then you can get to the other image. So if, let's say, as an attacker, I really wanted to gain access to this image of the BSD daemon, or demon, however you pronounce it. So I knew that the system that was used to encrypt this daemon used the same nonce every time. So I could just encrypt a image of Tux the penguin and encrypt it, zor those two ciphertexts together, and then I'll just zor it with the original Tux the penguin image. And if I do that, I will receive the original BSD daemon image. So that's cool. This does happen in real life. I don't think it's as common as ECB, or at the very least, it's not as reported as ECB. Initialization vector reuse doesn't exactly make the news whenever it happens, but it's happened before. An early example I found that was pretty high profile was the Sony PS3, where they used ecliptic curve digital signing algorithm, and they used the same K, which is the signing or the nonce that they use, it's a similar concept to initialization vector. It's a different mathematical formula. But if you use the same in that one, you can recover the private key, which allowed people to run unauthorized software on the PS3. Slightly more serious than unauthorized software on a PS3, Android Bitcoin wallets had the same issue as the PS3, which allowed for the private keys for other people's wallets to be recovered and then just be stolen. Not great. In 2017, a very high-profile attack to WPA, Wi-Fi Protected Access 2, was found, where you could force the server, we're going to talk about this a little bit more later, you could force the server to reset its nonce counter, and that would allow you to recover like traffic between victims and the server. And we'll talk about that a little bit more in a sec. On the Android friendly file sharing system, they properly generated initialization vectors at 64 bits randomly. They did everything perfectly, and then they truncated them to 32 bits. If you do that, you're going to cause collisions because it wasn't meant. It wasn't meant to do that. If you generate an IV, just take the full output. Don't truncate it. I feel like that should go without saying. In a very common OpenID usage, which is it's like Duo Security, it's an authentication app, they hard-coded the IVs inside AES GCM, caused the issue we just talked about. That's cool. And recently, another router, I don't know what it is with routers and poor security, they used an identical initialization vector for every web session. So don't buy routers from Tenda, I guess. So how does this happen? Well, one of the ways this can happen is just bad RNG. I don't have the requisite knowledge to discuss how RNG functions work really, but if your RNG function isn't properly generating random numbers, then it's going to cause collisions of initialization vectors and nonces, and you don't want that. More commonly, however, it's usually just logical or API misusage, like hard coding the IV. Don't do that. You shouldn't, that I feel like that should go without saying. Or just doing weird things with the IV after it was generated, like truncating them. Don't do that either. Don't like mess with the IV after it's generated. These algorithms are designed to create one IV of a specific length and make sure those don't conflict, not of like half length. Other ways this can occur is, if you recall, I mentioned a counter. Counters are great because there's no chance of collision. It's a counter. It goes up. You count 1, 2, 3, 4, and so on. Problem though, if you run out of space for the counter, then it's going to wrap around. Also, if you restart the counter, then it's going to start spitting out duplicate IVs or nonces. You don't want that either. This is in a similar vein to the to shared states between like VMs and the like. If two like users or tenants or threads are pulling from the same pseudo-random number generator, they can emit the same IV or nonce in different contexts, which is not great because that can cause collisions. This can also be exacerbated by the fact that you could take a snapshot of a VM and then roll it back, and then you could restore old states for pseudo-random number generators, and you don't want that to happen either. And then lastly, sometimes the attacker itself can just ask the server to reset their nonces. This was an issue in Wi-Fi WPA2, where during a handshake between the client and the user, the first two messages just set it up, and then it expected a third message, which was the signed anons key installation message. Since the server was designed to be fault tolerant, it would accept this message up to 3 times, meaning that an attacker could capture this packet, wait for a secure conversation to happen between a victim and a server, replay this packet, and then reuse these like nonces and information to decrypt all of the victim's information over WPA2. This was fixed in WPA3, but it was still pretty bad. So how do we prevent this from happening? Well, make sure that your counters and like IV generation things are separate, that they don't reset, or they should rekey before they reset. They make sure that you're doing API properly. You don't hard code IVs. That happens. I found a lot of those when I was like digging through like vulnerabilities on the trackers and the like. I just don't know why. Whatever. And dependency hygiene. This is the same thing with ECB. You should look through transitive libraries. Make sure that your libraries that you're using aren't having bad cryptography. I know it's a lot of work, but it's worth it if you're making a really secure app. One more. So let's say you do all of that right. You're using the latest versions and you're using it properly. Well, as an attacker, I don't really like the fact that things have gotten like better in recent years, or things have gotten more secure in the recent years, rather. Or well, sometimes you can just ask the server nicely to be insecure, and this can happen. Like this is more common than you would think, where the server, for the sake of maximizing compatibility between potential clients, will just allow you to downgrade yourself into really insecure, old, antiquated ciphers or technologies. So this can happen in a lot of ways. The web is the most common example. If a server allows you to downgrade to TLS 1.1 or 1.0, you can do something called the Beast attack, or I forget what that was short for. But this would require its own section to explain specifically how it works. But effectively, due to quirks in how TLS and ciphered block chaining mode work, it allows you to guess each individual byte of a encrypted block instead of guessing the entire block. So rather than you having to guess an entire 8-byte block, which has 200 potential characters per block per byte, which would be like 200 to the 8 possible combinations, you can just guess one at a time. So if you're looking for a 10-digit code, you can just guess 100 times, and then you'll get it, guaranteed. So that's not great. If you downgrade further than 1.1 down to SSL, there are issues with oracles, where you can excuse me. These are issues with older ciphers and servers where they would provide too much information about incorrect padding or errors that occur, and that allows you to slowly determine the key that was used to encrypt the plain text. Or better yet, if you get it low enough, you can just get ciphers that are completely outdated and can be brute forced by modern computers today. So that's cool. In the mail realm, you can also just remove the start TLS header on it, and if the email isn't configured to force TLS, all of the communications between the client and the mail server are going to be in plain text. Usually these are enforced by default, but there was 1 or 2 cases of this happening. This issue also exists for SSH, because SSH also negotiates between cipher algorithms between like client and server, or client and client, if you're doing that. So it exists in a lot of ways. So I just threw a lot of things at you. So what's the point here? Well, if you recall, I asked at the beginning, how are we going to attack this ciphertext? And the answer is you don't really. You don't really beat AES in a fair fight. You can't really do that. But this wasn't really a fair question either. You're not really ever going to encounter a lone wild ciphertext in the wild that you're trying to break. All of these things are built up within their own systems. All of the failures we talked about today, the ECB leaks, the nonce reuse, the downgrades, these were all implementation flaws. They were failures due to human error, ecosystems, legacy, dependencies, all that sort of stuff. Not to say you can't attack the algorithm directly. Quantum breakthroughs in like Shor's algorithm and Grover's algorithm, which I wish I had the requisite knowledge to talk about, it's really cool, is making those less secure. But that's all the more reason for us to not just depend on any secure algorithm and just, think of security as, guardrails, reviews. Security through community, if you will. And that's all. Thank you. Questions? Professor?
Yeah, on slide 12, you were talking about
Which
being
one?
able to break if you had a very common prefix sequence.
Yes.
Is that dependent on the block size, or what are some other the other prerequisites for that attack to be launched?
Yes, I have an answer for that. 1 sec. Did I say that? Yeah. So long as the password fits within one block, in the case of AES, that block is going to be around 16 characters. It's going to be the same. So if a password starts with 1, 2, 3, 4, 5, 6 here, but then goes off into something else, it's going to be a different, entire ciphertext, but the prefix to that ciphertext is still going to be the same, since it starts with a fully different block, if that makes any sense.
Right, so you're talking about a 128-bit block size.
Yeah. Okay. Anyone else? Thank you very much.
Wait,
Oh,
I had one before. You go ahead.
Okay, you.
I noticed on slide 2 and also the last slide, whichever is closer, probably slide 2 from here.
Yeah.
The string XVHUS, et cetera, shows up several times. Any significance to that string in particular?
On this slide?
That one and the previous one.
This is ciphertext that I got from Googling ciphertext. So I have no
So
idea.
You didn't decrypt that your own? Or
No, I did not end up decrypting this. I'm sorry.
That's okay.
No, I'll do that for my next honors option.
Very good.
Okay, Joseph, if you wanted to store your keys in a secure location, where would you put them?
Inside the AES block
That's
cipher.
right. A RITSEC lanyard.
Yo! Thank you.
All right, guys. That's everyone for today. Thank you for coming to the meeting. I appreciate you, all the presenters, Joseph and John. Thank you for your presentations. Very interesting. Oh, yes. And if you use the things under the table, plugged in, make sure to close those and unplug and make sure they're closed properly. Thank you. Bye, stream.